Hey everyone, welcome back to the Math Hive, and today we will be learning about trigonomic ratios for the right triangles. Let's get right into it. Sine, cosine, and tangent are all trig ratios to find missing sides of a right triangle in trigonometry. If you only have one side and an angle other than the 90-degree one to work with, you can find a missing side or even a missing angle. You need a calculator in the degree setting for this unit. The ratio for sine is sine theta over opposite over hypotenuse. For the ratio of cosine, it's cosine theta equals adjacent over hypotenuse. And lastly, the trig ratio for tangent equals tangent theta equals opposite over adjacent. It's very important to know which ratio to use in different triangles, and a simple way to remember the ratio is called SOHCAHTOA. SOHCAHTOA is a good way to memorize which trig ratios use which sides of a triangle. And it's important because you can use this to figure out which ratio to use to figure out which side in a specific triangle you want to find. So for it means sine, and the O and H stands for opposite, and hypotenuse. For ka, it's cosine, and the A stands for adjacent, and the H stands for hypotenuse. And for toa, it's tangent, and the O and A stand for the opposite and the adjacent. So these are the ratios that are important in trigonometry. Let's find the following trig ratios. First, we have a right triangle here, and we want to find sine of C. So let's use a formula for sine. So sine equals sine theta over opposite over hype. And first we can replace theta with C because that's the angle of interest. We're trying to find from this perspective. So sine equals C, sine C equals opposite over hypotenuse. And then we can just fill in what we have. So sine C, the hypotenuse in this case would be 15 because it's on the opposite side of the right degree, and it's also the longest side of a triangle. So sine C equals opposite over hypotenuse, which is 15. And for the opposite, the angle opposite to angle C, the side opposite to angle C, is 12, so we can also fill that in. And there we have it. So sine C equals 12 over 15. Use trigonomic ratios to find missing sides of a right triangle. So first, let's solve for side x. Using trig ratios, let's first label the hypotenuse, opposite, and adjacent side. So first of all, the hypotenuse is this one because it's the longest side, of course, and it's on the opposite of this right degree angle. The opposite is this thing, because it's the opposite from the angle of interest, which is this one. And the last remaining side is the adjacent side, which is this one. We need a ratio which includes opposite and hypotenuse because they have values of interest in this equation. So using SOHCAHTOA, we see sine theta equals opposite over hype, which is just the side we need. So let's write the formula down. Sine theta equals opposite over hypotenuse. Let's plug in our known values into the formula and replace theta with 58 degrees. So sine 58 degrees. And hypotenuse with 9.7. So we still have opposite missing because that's the side we're trying to find. And then hypotenuse gets replaced with 9.7. We also replace opposite with x because that's the side we're trying to find. And to further isolate x, we want to multiply both sides by 9.7. So let's do that right now. So times 9.7, and then sine times 9.7. After we cancel out 9.7, we're left with x equals 9.7 times sine 58. And to further help you understand, let's simplify sine 58 using a calculator. So sine 58 roughly equals to 0.848. And so sine 58 times 9.7 equals 9.7 times sine times 0.848 equals x. And we can use a calculator to further simplify this, which leaves us with 8.2, approximately 8.2. So x equals 8.2. So we figured out the missing side. Let's do another right triangle. We have triangle XYZ. Let's first label the hypotenuse, the opposite, and adjacent angles. So the angle of interest first we're given is 37 degrees from here, which will help us figure out what the hypotenuse, adjacent, and the opposite sides are. And then we're also given 9.2 as this side right here. So with this information, we can deduct which sides are the hypotenuse, the opposite, and the adjacent. So the hypotenuse is of course this one, because it's the opposite to the 90-degree one. The opposite from the angle of interest is this one, the side that's 9.2 centimeters. So we can put opposite here to label it. And then for this side, the remaining side is the adjacent angle, which we're trying to find right here, which is x. We want to utilize a ratio which utilizes opposite and adjacent, since the hypotenuse isn't the side of known value or the side we want to find. We need to use tangent theta. So let's use the formula right here. So tan theta equals opposite over adjacent. And then plug in the known values. So tan, we know the degree, so we can replace theta with 37. And then we also know the opposite angle is 9.2. And then we can just replace adjacent with x, because that's the angle. Let's isolate x to find what the value of x is. So the first step into isolating x is to multiplying both sides by x in this case, because x is on the bottom of the equation. So let's multiply both sides by x. So tan times x, and this cancels out, so we're left with x times tan 37 degrees equals 9.2. And to even further isolate x, we can do tan 37 and divide it by both sides. So like this. And then we're canceling this out. And so x equals 9.2 divided by tan 37. So we have this equation right here. And then tan 37 degrees using a calculator is equivalent to 0.7536. So let's just write that down to make it even more easier to understand. So 9.2 over 0.7536. And what this equals to once you put it in a calculator is around 12.2. So the final answer and the measure of this side is 12.2. That's all for this video. Thanks for watching, and I'll see you next time.